So the time is right, and it's about time to get started. So my name is Rustam, and I will be talking today about Java applications and modern Java applications. As you have seen probably from the announcement and from the slide that you see on the screen, it should have been two of us. So my colleague and a friend of mine, Mats, should have been here, but due to some family stuff, he couldn't join last moment things. You know how life is, you know, things happen. So I will be doing this thing alone, and that's a little bit scary. We did not plan on this at all, so you know, just bear with us, and we will hopefully get through this in one piece. I think it will be fine. So what I would like to do is to actually have a bit of more like a conversation with you. I do have slides and I do have some code, and I will be trying to switch between those. But you're more than welcome to ask questions, and I hope I will see them on the screen. And if I will not see them on the screen, I will probably get someone. Somebody will probably read them for me and just stop me and say that if there's any questions and stuff like that. So feel free to ask questions anytime. Let's try to make it a bit more of a conversation rather just than me just doing this on kind of in a broadcast mode, because the idea is that we'll try to do a workshop, but you know, since we are in situation we're working from home, we're broadcasting from home, we're doing all these things from home, we're not together in one room, and it's a bit hard to do like a traditional workshop. So let's do it a bit more of a kind of a conversation and chat and stuff like that. So let's start with the presentation, and the whole idea is, I mean, it's not a very big surprise, right? With all of us working within IT, we write code. Most of us, I mean, most of the time, most of us, we do write code. We do have this kind of, I mean, it can be our work, it can be our hobby project, it can be anything really, but usually it happens is that you write some code and you want to make it available somewhere. So, it can be different when you go to university and you study computer science and everything. Your idea is to make solve some kind of problem and deliver it, and just get it delivered, and somebody will check it and say, it's okay, and then you'll be done with it, and then you can switch on to another one and another one and another one. But when you start working, you have customers, or you have your employer, or whoever that might be, where you actually write your code and you'd like to put that thing into production. So not a big surprise yet, right? I mean, this is how we do things. And I have been working in the computer IT consulting industry as a developer for 16, 17 years or so. So it's been for quite some time, and I've been writing code most of my time, and most of my time while working, and also sometimes not working as well. So a few words about myself, by the way. My name is Rustam. I live in and work here in Oslo, Norway, and I am a Java champion, and also I'm a Google developer expert for cloud. So you can ask anything's Java, anything's cloud. I'll do my best to answer. And that's, I guess, very short introduction. I'll share some links where you can find me and where you can ask questions and everything a bit later. So for this workshop, we decided to use a very, very simple application, because the idea is not to write code. I mean, everybody kind of expects that you as developers, well, you know how to write code. We don't really need to do that. So we need to talk about more how we create those modern applications, and modern applications with Java. And things that we're going to show you here, and things that we prepared for you here, is is kind of, to some extent, is opinionated because we had to choose technology, we had to choose things. So first, the things we had to do, well, we had to choose which language it would be. So it's kind of naturally fell into Java. Okay, fine. But then we had to choose some other things that I'll show you along the way. But at the same time, while doing all that, we tried to keep it to as open source, as accessible as possible, and also if it is a proprietary thing, I mean, for instance, like a public cloud, we also talk about like about alternatives and stuff like that, because, well, obviously a public cloud is not something that is absolutely open source, but then you can always choose products that will go into the open source category or not, right? So the application was very, very simple on a purpose, and we created an application that would read 2 lists of words and return a string containing 2 words. So it would contain a noun and an adjective and a noun, and adjective and subject. So the thing is, so the idea to this thing was it was a little bit inspired by a authentication, like 2 multi-factor authentication thing that we have here in Norway, and you probably have it in Turkey as well, and in one way or another, and you probably have seen it in other things where, for instance, if you don't give your name to your Docker containers, Docker will kind of try to give it some kind of random name and stuff like that. So this is kind of the idea. You have 2 dictionaries of words. You go into some kind of URL or something, and it will give you a string containing 2 words at random, right? So if you go to this URL, it will be this. And if you go to the same URL, just refresh it again, it will be another one and another one and another one and so on. So the first step is to, with all kind of application development things, is to write the logic, right? So you have to write the logic, and that is pretty much it. So I mean, this is very, very little magic happening here. It is just 4 lines of code, and that's pretty much it, right? So there is nothing magical really happening here. We have actually, this is a bit more complicated example than I can show you in my IntelliJ. So now you should see the thing. So we created a separate repository for this workshop, where we tried to do different branches and stuff with different stages of things. So the first step, as you can see, we have 6 steps here. As you can see, step 4 is missing, but that's not because that's more because of it's a bit more of a logical step. There is not that much code for this thing. But anyway, let's start from the beginning. First step is, the logic. So kind of originally we started with this text file where it was a little bit of code. But that doesn't really run, so we put all that thing into actually a Java file with super simple thing, like you have a few methods and you have a main. There is nothing else happening. In addition to that, is it big enough, by the way? I mean, if you want me to increase the fonts and stuff, just let me know. I'll try to do that. I'll try to zoom in or go into presentation mode or something like that. But I think it should be fine since I have the window is smaller. So please write in chat if you want me to make it bigger or something like that. Give me a second. I'll just this sound. Sorry about that. There is always someone that has to do something outside and make a lot of noise when exactly at the same time when you do the presentation. So logic, very, very simple logic. We have 2 classes that are basically enums containing adjectives and another one containing nouns. The idea is you'll pick 1 word from each and you put them together in return. That's it, right? So the simplest way to write this thing and make it work, well, you create a main file and you just just make it run, and then it's supposed to work. Let's see if, yeah, it's perfectly failed. Let's see, I need to rebuild it because I built it for another, I did build it for another step. So if I rebuild this thing, it hopefully will work. It did work a second ago, and now it is just messing up everything. Isn't that fun? Let's see. That's why you don't do alone. You're not alone when you do this kind of presentations. That's one of the things that rebuild the project. Come on, help. That's some kind of IntelliJ fun. It just did work a second ago. No, it doesn't. Edit configuration. What is wrong with you? Local machine, blah, blah, yes, yes. But, well, I mean, the point is, it does run because, I mean, there is not that much thing. I mean, we can actually see that it's supposed to run. It's just my IntelliJ being a bit strange. What is with you? What's up with you? Could not load the main class. Why can't you do that? Because I need to compile, and I thought I did. Well, okay, let's not spend much time on this thing. Anyway, we have a logic, and that's supposed to return us two words. And if we go back to the presentation. So this is kind of typically where you start, and most of us will go through this project or thing that will run the logic, and it works locally on your machine, and then it's fine. But then you get to this point, is like, okay, fine, it works on my machine. What do I do now? Because, you know, writing files. I mean, for me, it's been quite a while since I wrote code like this. You know, with the main class and with all the other things where you just, you know, run things. Usually it's a much bigger systems, it's enterprise kind of thing. It can be some kind of REST API based kind of thing. And, you know, even if it's not, then it will be much bigger thing with lots of libraries, and you don't do, I mean, how often nowadays you do write some things like that, right? Saying like, you know, random strings equals new random strings and stuff like usually you do some kind of CDI for that and all this kind of thing. So this is on purpose, super simple thing. And if we go back to the presentation, just making sure that I pick the right one, yes. So we have this code, right? And then we have to, the step 2 would be to actually run it. And running that code would be, you know, like I did, well, like I tried doing rather, but my IntelliJ failed. It's kind of fun. You test it half an hour before, it works perfectly. You do it in the presentation, and there is something going horribly wrong. So, you know, anyway, the running code, you do run it on your machine and it works, but then it's not enough really, because you need to do something more about it. You need to put it on some kind of, for example, an application server, right? And there are quite a few of those. Or you need some kind of framework, actually, not only application server, but you need to have some kind of framework. So say we want to put it on the web with a REST API with some kind of API available, or a part of an API, or, you know, it depends on how you're going to implement. In our case, we're happy to see something that I showed you earlier. So if you go back, something like this, what you see on the screen. So if I go to a localhost URL at a specific port, at a specific URL, it's supposed to return me a string. So I'm happy with that for now, right? So how do you do that? How do you make actually all those things? Of course, you can write it yourself. I mean, I've experienced some people, I talked to some people where they would be like, you know, the most extreme that probably people that I talked to, they said that, well, you know, application service is nothing for me. I like writing things from the bottom up myself. And I guess you can do that, but it depends on how much time and effort you want to spend on this, right? So what we decided to do, and what we decided to use in this case, is a pretty cool library, or actually this is not a library, this is a specification, but we'll get there in a second, called MicroProfile. So MicroProfile is a kind of, I guess, the short version of explaining it. If you haven't used that, if you have used the chat, write it, and if you haven't also used the chat, and write it. So just let's see how many people have used it or haven't used it. We did a few talks about MicroProfile, so you might have heard about it. You might have heard other people talking about MicroProfile. It's a pretty cool thing. So MicroProfile is actually a specification, and it is not just a specific application server or something. It's actually a specification, and in a short way of explaining it is kind of like Java EE was to Java, the main, to the monolithic applications of Java and everything. This is Java EE for microservices. So it contains a list of very useful technologies or useful libraries that will help you create microservices using Java, and deploy those in a quite effortlessly, should I put it that way. So, we kind of started answering that question already, right? What is this thing? Well, it is like a microservice friendly Java EE version, or Jakarta EE, or whatever that thing is called. And the reason that was started was also that back then Java EE, or what now is Jakarta EE, was kind of a bit slow, and there was not that much things happening, and there was a need to have something like that for microservices for modern applications. So MicroProfile kind of was born by several people in the community going together and starting putting it together. And what is this thing? So that is pretty much what you see on the screen. So we're using here MicroProfile 4.0 that was released, well, relatively recently, end of last year, so 5 months ago or so. As you can see here, all of those packages are in blue, but normally in between minor releases, not like big major releases, some of those boxes that you see there in blue would be maybe left as they are, or they may be slightly updated, or maybe added and everything. So after a while, MicroProfile spec got stabilized, so there's not that much new stuff coming in, more or less, and usually it will be like some of the libraries would get it updated. So as you can see here, it's a lot of things that help you a lot with creating microservices. So if you want to create it, to put our little application that will be returning 2 words for, I don't know, multi-factor authentication, or for naming things, or whatever that might be, and you want to put it into a URL, and then you can call that URL, get the string, and use it for whatever you're using it. You might need to have, I don't know, let's say, well, you definitely need a CDI, right? So you need dependency injection, or you might need some kind of JAX-RS or this kind of stuff to actually return and consume JSON and all those kind of things. Or you might want to provide some metrics to tell how well that application is behaving, or if it goes down, you want to default to something else, then you might want to introduce fault tolerance, or you need to put it behind a password, or behind some kind of authentication. Then you can use this JODS authentication thing, and all those kind of things. And there is a lot of cool things in it. There is for instance, you can use REST clients, so you don't have to write your own requests to consume some other stuff from other REST endpoints and things like that. So it's pretty cool. A little thing, and there is also on the right side, you see there that says a standalone packages. They're kind of part of MicroProfile, but kind of not. So the core MicroProfile is actually the ones that you see in the blue, but then you have some other cool things on the side that also can be used, but they are a little bit on the side of spec. So for example, you can add a GraphQL endpoint to your application, stuff like that. So it's pretty cool. So it's pretty widespread community of this thing, you know, because when we introduce a technology and I'm saying, well, you know, this is an open source technology, I kind of need to explain, I feel anyway, I need to tell, well, you know, who's behind it, because if there's not that much people behind it, or communities or companies, then it's, you know, you don't know how long it will gonna live or how long it's gonna be there. But this one, it's a lot of solid companies and big communities behind it. So there is, as you can see, I mean, there's a lot of big companies that you recognize, but there's also communities. There is like a London Java community, there's a Brazilian So Java community, there is Atlantic Jug, and there are a few others. So it is supported by companies, and quite a few of those companies that you see here on logos on the screen, they would have their own application servers. So that means that they would also implement that specification that was created by MicroProfile. So for instance, Red Hat would have one or several application servers supporting it. IBM, Cumulus, the little K in a cloud thing that you see there, or I don't know, so let's say Oracle, Tomitribe, Payara, all of them have their own app servers that would support MicroProfile. So that's kind of cool. And why exactly MicroProfile? I mean, so what is this thing? Why did we actually choose that? Our idea was to, exactly like I said, you know, you can write all those things from scratch. You can put all those libraries together from scratch on your own, but you know, it's a lot of effort, and it's much easier to concentrate on the fun part, that's actually writing your own logic instead of, you know, creating boilerplate code and everything. It means handling HTTP requests and JSON and the parsing JSON and stuff. It's probably very fun once, and it's probably not as fun for the 5th time you're writing it, or something like that, or maintaining the whole thing, or, you know, all those kind of things. The other thing was that the other thing that we really liked about it is that it's lightweight, and we've been playing around with it for quite some time. We've been using it in different hobby projects. So quite a few of them were also Mats and I were working together to build them. So we built some kind of IoT lights that would be controlled by some small microservices built in MicroProfile. We did this little application, and we did a few other things, just because it's so easy. One of the things, it's so easy to build a web-based application without thinking much about all those things. So, you know, lightweight, I guess, goes very well into that category. The other thing is that it's interchangeable. The other thing is that it's interchangeable, because that means that you can actually switch between the application servers. So you can, you know, you can run stuff on OpenLiberty, and the other second you can switch to, I don't know, say Tomee or Payara, or, you know, any other kind of application servers, and most of the cases, and it should work. It should be fine. So that's also a pretty cool thing. I have been told that there is a question, but I'm not really sure how I see that question. So go to the project structure, and so that was the answer to what was wrong with this thing. Thank you very much. Go to the project structure and set source file. I should probably do that. Well, okay, anyway, we can do that later, but thanks for the tip. It's probably that. I mean, when you are in presentation mode and there is like a camera lens and lights and everything pointing at you, sometimes I forget what my name is, you know, so you forget basic things. That's the point. But fortunately, I don't forget my name that often, but I do forget setting up things in my IDE, apparently. Anyway, so if I'm not going to talk too much about MicroProfile, but if you kind of want to try it, take it for a spin, and I mean, I'm I am the only way I'm involved in this project is that I'm helping a bit here and there with MicroProfile, so I'm not really gaining that anything from selling it to you or to kind of making it available for you. But if you want to try it, if you want to take a first spin, it's a pretty cool thing. I like it, so that's why I'm kind of advertising or advocating for it for free. But if you want to do that, you can actually go. There is, as you can expect on other similar things, like, you know, there is a Spring Boot, there is another one, there's a few other ones that offer similar-ish functionality. I mean, they're not similar in the way they are, but they're similar-ish functionality. If you want to do that, go to start.microprofile.io. There you can create your own artifact and download it, and then you can just open and continue writing your stuff in it. We're going to do that as a part of the in our workshop. So actually, we're probably going to do it even now, because we're actually coming to this step that, you know, now it's supposed to work on my own machine. So now if demo gods are with me, that is a big question today. We'll see. I see why now it was not working. Huh. Okay, let's see. So if we go to Git, and so step one was just bare logic, and you can actually, I mean, I'm going to share the link to the repository, and I need to switch screens so you actually see what I'm doing. So I'll switch to this one. All right. So as you can see, there are quite a few commits in here, and you can also see the tags for different steps. So we're going to share. I'm going to share the link to the repository there. If it's on my GitHub, so you can actually play around yourself. It has just been created just a few days ago when we were preparing for this workshop. Normally we do this as a talk, so we more refer to another repository that kind of contains all of it smashed together. But now we want to do it step by step, so we decided to split it up. So if we go to step 2 of the whole repository, what happened here is we did, as you can see, the files with all the logic and everything are gone. I mean, they're not gone, but they have been moved. Now we have a little bit of a structure here. We have a little bit of, like, all of a sudden we have a README here that is not written by me. It's been auto-generated. All of that been auto-generated on this page that I showed you earlier at the start of microprofile.io. I did that on purpose because I just wanted to show how easy it is to do this kind of stuff. So and you can actually see that also in the commits. You know, it's how the logic was moved around and everything. So it's traceable there as well. So if we open the right package within our structure, we'll recognize our files that we've seen before. So it's the same one with adjectives, nouns, and all of a sudden we have a few extra ones here. So we have a few things that are, so in this demo I'm using Open Liberty, and Open Liberty, when you choose that in the starter webpage thingy, it will create a few extra files that are specific to Open Liberty. So for instance, there are a few things like a server XML and stuff like that, where you can where you define ports and where you define it's supposed to be a feature things here. Yes, exactly. Feature manager and all those kind of things, which is specific to Open Liberty. But in reality, what you can do when you want to switch between different application servers, you can just change a POM file that where all of this kind of things are described. You choose another POM file, you build with that POM file, and then you're done. That's it. It's pretty straightforward. But what happened inside here is that we have application path that we defined to be in just /API. It could be just /, but you know, we just did that. And as you can recognize, I mean, if you have been developing Java for some time, and if you've been working with Java EE, Jakarta EE, whatever that was called or is called when you've been using it, you'll recognize a lot of things. So annotations is kind of thing that you recognize from there, and there is not much of a surprise here either. We have from the root API, whatever that might be. In our case right now, it is localhost. Then we go to /API, and then we go into an application, and there is no code in here, and that's fine. What actually happens, all the magic and everything happens. Let me close that so we actually get some more space. So most of the magic is actually happening in here. And here you'll actually recognize a lot of things that you have seen earlier in our main file that wouldn't work for very, very embarrassing reasons. Anyway. So we have get random strings that would return on slash, but that's slash relative to the API. So that means API slash, right? And it would return us a string, and that's pretty much it. So if we actually, what we can do is to write. Now, okay, let's make it work first. Let's see if it works first, and then we can. Where's my terminal? There's my terminal. I can do maven clean package, not maven clean install, just in case you wonder. Maven clean package. So we do that. It takes a little bit of time, a few seconds of what can be an awkward silence, but I just, keep on talking, so it won't be that awkward. So what happens now is that we're getting actually a fat jar, so a jar containing everything. So I can actually run this in from my machine using just java-jar target / random strings.jar, because I called my artifact for random strings, as you can see here in artifact ID in POM. So now, if everything goes well, because now we're actually not using IDE, and it's supposed to give me a, let's see, let's do a little crazy thing. We can actually do, instead of switching between browsers, okay, so now we're up and running. And you can see that MicroProfile added a few extra things. It actually built things with extra URLs available. If I can go, for instance, to health and see how the application is doing, or I can see all the documentation of APIs using OpenAPI and so on, so on, so on, so on. So now it's running. So now we can probably, this is fun. This has not been done before, because we were supposed to be 2 people doing things together and stuff like that. But okay, let's see. We get. We can do like HTTP / localhost colon 9080 /API and see what happens. So we got something back, and then we can see what actually we got back. Hey, it's tough well. Okay. So we can do that again, and we'll get another file called API.1, and it's a soulful maestro. Oh, that's nice. All those words are random, so if anything strange comes up, don't blame me. I'm just saying this one was actually nice. Soulful maestro. It kind of feels. But anyway, so now it works on my machine. So now it actually works in my machine. I'm not doing like main public static void main and stuff. I'm actually running a tiny little microservice running on my machine, but it works on localhost. That is the problem, right? So this is exactly the same thing here as well. We can just keep on refreshing and probably make it bigger. Mighty encourager. Ooh, that's a lot of nice. Okay, so I like that. Gorgeous. Okay, famous fun. Now, enormous fun. Yes, that's what we're having. Okay, perfect. Well, we'll stay there. So now it works, but the problem is that it's still local host. It's still actually my machine. And with microservices, there is not that much fun when things work only in my machine. And as someone once said, you're not really paid for making things work on your machine. You're actually getting paid to make it available for others and everything, right? So what do we do now? The next point, again, this is a few steps of a typical app modernization thing, and some of them might think very obvious if you worked a lot with this, but believe me, there is a lot and a lot of people that are not there. If you are there, if for you kind of containerizing applications is like, yeah, of course I do that before breakfast, I mean, that's no biggie. That's really, really cool. That's awesome. But there is a lot of people that are still, I mean, still, year is 2021, they're still playing around and looking into possible containerization. So, you know, containerization apps of the apps is actually quite an important part of making them more modern. And containerizing apps is more than just shoving everything into one container. If you take a huge, enormous monolith of an app with many gigabytes of footprint, of memory footprint, and all the other things, and you put that thing in the container and just make it run, that is not containerization, really. But, you know, in our case, we just kind of want to package the whole thing into a container. So, what do you do? Well, obviously, you can use Docker. You can use other container technologies or products to containerize things. We're using Docker here, and we are also want to underline a few other things, important things. When you create a Docker file, it is very, very nice thing to actually build and deploy your stuff within Docker containers, because you'll make it much more future-proof, as you will see in a few slides and a bit in the future, where we're going to put, spoiler alert, into the cloud. When you do that, you might want to kind of make your build environment as predictable as possible. And the way of doing that, that's putting things in the containers, because if you run it on local in machine, back in the good old days when we used to have build servers just running installed Jenkins on a machine that would pull up your stuff and build it and just put it onto some kind of test server, and then when you put it into production, it would build it in a totally different way and it would fail, and then you would have no idea what happened. You know, those days kind of are gone, because now you can put things into containers. And to do that, to make your builds as predictable as possible, it's a very, very good idea to use multi-stage builds. What is a multi-stage build? Multi-stage build is basically you define several container or like Docker files after each other in a way, and you tag them, and then you pass along artifacts that are being built from one to another and to another and to another again. So in our case, we use Maven to build this thing, and as you know, when you build with Maven, it downloads half of the internet. I mean, that's how it works. I mean, Maven is a fantastic and amazing tool, but it downloads a lot of data and it leaves a lot of data on your disks. And so you don't want to do that on somewhere in the cloud, or you don't want to do that on your running. Please don't do that on your running containers that you deploy to production. So you would have a container containing Maven with, you know, everything installed there. You build your artifact, you create your jar, and then you pass only that jar to a next container that will be actually running the whole thing. And then you kind of discard this Maven build container because you don't need that anymore. Next time you'll do that, you'll kind of create it again. You'll create it again from a specific version, and also a very good idea to specify and to make sure that you can keep track of the versions and everything in your Docker file of the distro, of the other things, and of stuff installed in it. For instance, don't do just the latest of Maven. Maybe that might be not a good idea. You will be running on the bleeding edge, but you will be running on the bleeding edge, right? So slim base images is another thing. From security perspective, is a very important thing, because you don't want to have extra stuff installed on your containers, making it more more available for hacking or for some kind of attacks and things like that, right? You just want to make it as little as possible, just enough to run whatever you're running. And all those kind of things are very, very good practices when it comes to developing stuff with Docker. So let's go back to our IntelliJ. There it is. Okay, so now we will try to do, let's see, first we'll close this one, we'll kill this one. Okay, we'll go to Git, we will go to step 3, we're gonna check it out. So now we got a few files extra here, so we can delete those API files. Just do a little bit of housekeeping. Let's go away. So as you can see here now, we have a multi-stage Docker file. Yay! We actually have a thing, as I told you, we have a builder container that is a 3.8.1 Maven with JDK 11, and we copy our source code to that thing, we build it there, and when we're done building it, we pass it on to another container that contains OpenLiberty, and that is our runner container. It also runs on Java 11, and yeah, that's pretty much it. So what we can do is to, let's see, we can do like this. You can actually run it, and we will see. Yeah, I think I know what's the problem. Start the Docker instance. It will take a little bit of time. So the point is that now we're building containers. So, but we're still on localhost, and now we will soon, after my Docker engine is done starting up, and after all the fans on my laptop are done spinning up, because that's what happens when you run Docker with all the other things on your machine and million of tabs and everything. So maybe now, yes, we are on. So let's see, there's, okay, that one is working. So now we can actually run our Docker file, and it will be doing downloading of first the Maven control container, building the whole thing, passing, kind of throwing away the main Maven container, passing the JSON, the jar file over to the OpenLiberty. Now we have things running on our machine, but already in the Docker. So now we're actually getting ready to something kind of cool, because now we wrote our logic, we've chosen how to run that logic. So we kind of picked a framework, and then we kind of picked also a application server. So here I picked it for you. I just picked OpenLiberty just because. It could have been anything else. And now we're putting things in a container. So now we're actually making it very, very predictable how it's going to behave and how it's going to build. So if it builds here without any problems, and so with my track record of demos today, I will keep my fingers and toes and everything crossed that it actually works. And it's very, very interesting. It's demos are always fun. And obviously it pauses a little bit to build up a bit more suspension, suspense in the air. But now we have an application actually running in the container that is very, very predictable. You can actually give someone else that container or a Docker file containing that, and you will know that most likely it will be actually working as intended. So now you can see it's doing the same thing of pulling layers and everything for another container, because that means that's actually done building, done doing all this Maven stuff, and now we're actually pulling down the OpenLiberty, and maybe it's even running. That's going to be interesting to see if it does. Yeah, so no, it's step 8 out of 10. So that means there will be a few other steps happening there. But we don't really have to wait for that thing, because this is kind of still a bit of a basic stuff. We know that it's supposed to work, and we can go back to that later and see how it's doing. Let's switch back to the slides. And in the meantime, are there any questions, comments? I mean, we've been going through relatively kind of the first steps of, the first things that you need to do to create your modern application. There are a few other things that I'd like to share, because now that we have it running in a predictable environment and the builds are predictable, the behavior of the application is predictable, now we can actually put that thing into the cloud. Because you remember, your kind of task was to create a piece of logic that is available for many people. When you run it on local host, it is available for only you, or maybe few other people on your local network or whatever. But if you want to make it available for more people than that, you want to put it on the cloud. And here again, back to this opinionated kind of choices that we made, we decided to go for one of the cloud providers. But containers, they run pretty much on any provider that out there that offers any kind of cloud services. So it doesn't really matter which one you're going to use. In our case, it is GCP, so Google Cloud Platform. So what we did was to put that thing there. But this is first thing that you might want to do when putting things into the cloud, because cloud is not, and now we're getting a bit more further away from this kind of old school way of deploying applications, because if you've had your on-prem application servers, you would typically, back in the days when I started working, which was 15, 16, 17 years ago, that was very normal to deploy it on servers on-prem directly onto the server. Then we started with the containers some years later, then we started with cloud some years later, and so on, so on, so on. But the thing is, it's important, very important part of a modern and kind of application that will be as little pain to deploy, to automate as much as possible. So you automated builds, you automated deploys, because you can do all this kind of things in the cloud, in the containers. But now you have to automate all that in the cloud. So what you would normally want to have is to have some kind of repository. So in my case, it's GitHub, and then you can create a trigger that will trigger on something. So it can be, for example, a new commit, or it can be a new tag, or it can be a new whatever, specific, or it can be even manually started if it has to be just a button. But you still just click on one thing and it will do all this build process thing for you. So what we've done here, I'm just going to show you real quick. So we did this thing, as I told you, on GCP, on Google Cloud Platform. Maybe I'll make it a little bit bigger. Can I do that? Oh, that's interesting. Yeah, I can do that. Sounds good. Okay, we'll go away, remove the recommendation. So now we have a bunch of triggers here, and those triggers kind of trigger different kind of things. So in our case, we want to see Open Liberty, and we can just run it, or we can see how it's configured. Again, I'm not going to explain how it's done on specific platform, because the idea is you can use any cloud provider for doing this. The more of this, the more is the idea of it, right? So you create a branch, you get it from a branch, you kind of, what would you react on, right? Branch, tag, and so on and so on. You define, you connect to a specific repository. So this is a repository where the whole thing is. So you can actually find that on GitHub. So if you go on under my last name and then MicroProfile Random Strings Workshop, and in there we have a branch. So in our case, it's step 3, the one that we've seen, right? And then you can just do stuff with it. And the way you do this stuff with it is that you kind of first you need to define how you're going to build it. So in our case, we decided to go with Dockerfile because it's as independent as possible from the platform and everything, because you can build Docker files locally, like you saw with that we did, but you can do it also in cloud, and you can also do it in other ways. And other ways would be, for example, you can define also a cloud build configuration YAML file or JSON file, where you can actually define all those steps in there. And then you wouldn't need to, for example, do like two-step multi-stage Docker files and stuff like that. Then you could just have a simple Docker file that would just run it, and then you'll do all the other things inside the build cloud build thing. But cloud build is a cloud-specific thing, so we do have an example of it. So you can actually go in and look. There are two repositories that are kind of interesting to look for. This is the main repository that we are working with right now, right here. So this is the one. But if you go one step up, you will see that there is also another one called just random strings without workshop. That one has all of the things at the same time in one big bang, or whatever. And this is an example of cloud build file. So very little magic, very little black magic, but it just explains what to do and how things should be deployed and everything, and that's it. All right, so automating builds is an important thing. So this is one of the things that we kind of wanted to show you there. But because this is actually pretty cool, because when you're done with all this automation and everything, you can just run, or you can trigger that things automatically. And when you do that, then you can actually, you can use that for some other stuff. So for example, if you go to history, you'll see a lot of attempts to build different branches. Some of them failed, some of them were fine, and that was, that's how you typically debug application and debug build scripts. You just try and it fails. Okay, fine, I'll do another thing, another thing. Oh, by the way, our Docker container might be running. No, it's not. Okay. Okay, so first step when you're going to cloud, automate your builds. We talked a little bit about cloud build. We talked a little bit of like choosing which one to choose. It doesn't really matter in that way, but if you want to go with more specific thing, go for cloud build that is specific to platform that you're running. Dockerfile, each of them would have their own pluses and minuses, so positive and negative sides. So now you have a container on the cloud. Now what? Because I mean, you have built a container. It's still not running. You've just built your container, and it exists somewhere out there. It doesn't really make you that happy. I mean, it kind of feels warm and nice in your soul, probably, but you need to do some more work before you can actually, share the happy message of, finally my microservice is available. Now we need to deploy it. So there are a few ways of deploying, and that's why step 4 is missing in our kind of, this repository branches, because step 4 is actually deciding how you want to run it. You can run it like you did in good old days, and with on-prem services and stuff. You can create your own virtual machine, put that containers there, and just make it run. You're done. That is not very cloud native way of doing it, but it works. You can also use cloud specific things. I mean, whatever your cloud offers. So there will be quite a few offerings on different clouds. So for example, on again Google Cloud, that would be App Engine Flexible would let you do containers. You could do containers, and you can run containers in virtual machines, like I said, but you can also run them in something called Cloud Run. Cloud Run is the one that we actually kind of landed on because it is a serverless offering, and it is another positive thing of that is that it is as little cloud specific as possible. Yes, Cloud Run is a managed service provided by on GCP, but it is actually Knative, managed Knative that you are running there. So if you haven't heard about Knative project, search for it and you'll see what it is. It's an open source initiative, lets you run containers, and the managed version, so you don't have to kind of install and manage the whole thing on GCP, is called Cloud Run. So that's why we landed on Cloud Run, and then all of a sudden we could actually run our containers on Cloud Run that would scale up and down automatically. It would even go down to 0. So you don't have to even pay for your container running when it's not in use, or when it's being used, it will kind of scale just enough amount of servers. If you have a huge surge of users, it will kind of scale up to a lot of containers. If there will be no users, it will kind of scale down to 0. But the other cool thing you can also do with all this kind of stuff is that you can do things like traffic splitting. So you can do red-green deployments. You can do, for example, very classic thing when you do app development nowadays. So when we're talking about modern app development again, it is to, for example, when you roll out new version, you do it slowly. You just don't do like big bang release, because bugs happen, things happen. You don't know how it's going to behave in a production maybe, or you want to test. You want to do maybe even A/B testing. You want to test a new functionality, or you want to test new API or new behavior. Can be different reasons for that, but what you can do is you can actually do traffic splitting. So say you have an application running, 100% of your traffic is going to that application, and when you want to release a new version, instead of just releasing new version, switching 100% of the traffic to that new version, you would say, okay, I want to redirect 5% of my traffic to that new version and see how it behaves. So 95% of the users would see no difference. They will still be using this old tested version that behaves really well and everything. And then you do 5% and you see if it behaves as it's supposed to. Oh, it does. Okay, cool. Then we can increase it to 20%, or then we can increase it to 50%. And then you can do it a bit more and see if it loads well, if it kind of works under pressure well, and if it does all those kind of things. So you can do this kind of red-green deployments, or you can do, like I said, A/B testing. You can deploy a totally new version and see, okay, let's 50% of my users getting old version, 50% getting new version. What is the feedback, right? Because all the big companies are doing that without even you noticing it. I don't know, like things like, say Facebook, they're releasing new features to some people and see how it behaves. If it works, they will roll out to everyone. And that is kind of the way of doing that. And this is a very nice way of doing that, because if something fails, it just failed for only 5%, and you can always just click a button and it will redirect all those 5% back to the old version, and you can actually fix the version that was about to get released but had some kind of bugs. So all of those things you can actually do out of the box pretty much with Cloud Run. So this is kind of cool. And again, it's an open source project down and at the bottom, right? So it's actually it's Knative. So now let's see if we can actually do that. If we go into, are there any questions, comments, anything that you want to share with me? Please write it, and I'll see that on the screen. In the meantime, we can go to Cloud Run, and we have, right.
Also, my friends, your microphones are open. If you want, you can unmute yourself and you can talk with Rustam. Hello, Rustam, by the way.
Hello, good to hear you. I don't see you, but I was about to say good to see you. But yes, and you can probably, I mean, it's been quite some time, but you can probably ask questions in Turkish. I mean, I should be able to understand that. I mean, my Turkish is getting quite rusty because I don't use it that much every day, unfortunately. But I should be able. I definitely understand, and it gets very complicated where I need to answer because my brain goes like, But
also, are there any question? I will forward it to you. No problem. So you can just concentrate.
Thank you so
Okay.
much. Thank you. We have applications, and we actually have quite a few applications here. And the cool thing is that, well, that was not supposed to happen, but we actually have security recommendations for this thing. Yeah, well, that's okay. That's okay for now. This is our tiny little demo application, so that's okay. It basically says that's another. Well, actually, you know what? We're talking about modern app development, right? So I will actually going to mention that. I wasn't planned, but you know, since it's there, I'll mention it. One of the very important things when you work with cloud and modern applications is to make sure that you have as little rights as possible, both you as a user, your service workers as deployers and stuff, you know, your service accounts and stuff, and also your applications and all of those things. Keep it as little access as possible, but just enough to do the work. So that's exactly what this warning is saying, is that you've given it too much permission. So this is a bad practice. Don't do that. But you know, this is a tiny little demo application. You can't really make bad things with it, except for really DDoSing it and just, you know, making it cost money. But we'll probably kill it after we're done with this talk. So it's okay. I mean, and I hope that you're not gonna DDoS me anyway. So famous last words, but you know, you're nice people. I expect, I know you are. I've been to the Java Days Istanbul quite a few times, and I know you are. So anyway, but the cool thing that we have different versions of this. So we have a regular one, the one that we've been playing around and building in different ways. So this is the one that is running on Open Liberty, and let's see if it's just let's go to can I allow unauthenticated? Yes, that's good. Okay. So what happens if we go in there? So this is an application that is deployed. There is no traffic to it, but there is a URL to it. So let's see if that works. So you see, there is no traffic and no data because, you know, there is nothing happening. There is no errors. There is all good. After that thing is done spinning up, and take a note how long it takes actually to spin up that thing, because now it's starting a new container, it's starting cloud build. It's still quite fast, but it's not as fast as it is as it can be. We'll see that in a second. But you know, this is now it's up and running, and now we should see some kind of traffic here as well, maybe. Let's see, maybe we can refresh that thing. So let's see if we go to the endpoint. So we just created a dummy web page that will kind of point to the right URL on for the API. Basically, it says the whatever random URL you get from the cloud /API//RND. So we created this RND thing. Compared to the one that we had just slash on locally, but here we just added RND for the heck of it. So every time I refresh this thing, that will give me a new, make it bigger. Out of sight, developed delight. Yes, that's what we're doing. That's a lot of nice words. It wasn't really planned, but you know, happy-go-lucky substance. That's not very good. Self-assertive. Okay. Well, anyway. So random strings, it works. It's in a cloud. It's in a container. We build it automatically just by a commit. And now we can actually do some other cool stuff with it, because now we can actually do, we can go into here. Metrics are still silent. It still did not pick up that it's been doing something. Let's see if there's anything in the logs, just to see that it's live, actually. Yeah, it's live. All right. It's you can see that it's responding to some requests and stuff, so it actually works. And still no data. Okay, it takes some time. But the point is that it works. Now what we can do is to switch to my presentation. So now we're here, right? We have this kind of weird URL and it works. Before we go any further, we probably should talk a little bit about when we should not do serverless, because I mean, this is, again, this is not, I'm not supposed to teach you how to write applications Java. You can do that. I'm not supposed to teach you just how to put things in the container or anything. I'm kind of giving you the whole story from a piece of code that you write to making it like auto-managed somewhere out there so you don't have to think about it, right? And serverless is kind of part of this journey, but sometimes you cannot go serverless or should not go serverless. And one of the most important things probably to mention here is that your applications that have state that do not tolerate being turned off and on again, like with this app, because you saw that it took like the first request quite some time because the application was sleeping because nobody was using it. It woke up, it kind of booted up the right container, it found resources to write that container on, it kind of, did all this kind of thing, it booted up the application, it returned the string, and then you got the answer. Now, if I'll be doing this refreshes, it will be really fast because now I have container and everything running for some time until it goes back to sleep, right? But if your application does not support this stateless thing, because for me, I don't care about state. I don't care about what application was doing before it went to bed or to sleep. I just, ask it and it will give me some stuff. But if you do care about state, serverless is definitely not for you. Or if you, for example, you have to do some other extra things if the response time is important for you. So you can still use serverless, but maybe you need to do it the other way around. Or for example, in our case, using this app engine, Cloud Run, that's how we're using, that will not work if you, for example, request a specific hardware. If your application or if your container requires a very specific hardware to run on, with this configuration, it will not work. It will not work with fully managed version. But there is another one called Cloud Run on Anthos that will let you do hybrid clouds. That's another thing that you kind of need to learn or to kind of keep in mind when developing cloud-ready, cloud-native modern applications, that sometimes you don't want to go all the way into cloud. Sometimes you have to do hybrid, or sometimes you want to do multi-cloud. So you want to kind of split between different cloud providers, or if you want to go hybrid, you want to go splitting resources and all this traffic and things between a cloud, a public cloud, and your own on-prem service as well. So there comes another thing called Anthos, but there are other providers have other things to do that. But basically, that will let you do Cloud Run and all this running as it is, as you saw on the screen, with almost no difference for the user. But you might be able running. You might be running that thing on your local special hardware. Say you need very specific GPUs or TPUs or whatever that might be. One thing I noticed, and I asked you to notice, do you remember how long it took to boot up the whole thing? I mean, when you think about it, and you think about all that happened in the background, it's not that long. I mean, we did wait for, I don't know, say what, 5-10 seconds, and the whole application was up and running. But in reality, it was a lot of things happening. So it's kind of impressive that it all worked in 10 seconds or 5 seconds, or how much it was, scheduler had to find resources, had to spin up things, had to make things work and handle requests and all those things and return you back booted application results and all this kind of stuff. But you can actually make it faster. So you can For instance, you can do things like setting up minimal instances, minimal number of instances. So you can, for example, your Cloud Run can go down to minimum 1. So it will always be there to answer your requests, but that will cost you money. What you can do and what you should do, definitely, always, anyway, is to make your application startup time as fast as possible, right? And there's a lot of ways you can do that. So you can optimize, and but there are a few things that will give you very fast gains very quickly with little effort. And one of them is that the runtimes you're running on. So the runtimes you're using. So now we're using. You remember we were using one application server, Open Liberty, and there is nothing. I mean, Open Liberty is great application server. It's not anything except for that specific app server. If I would have used a different application server of the same kind of grade, I would get pretty much the same results. I mean, all of those startup times for app servers, they're very quick, but they're kind of they're a few seconds kind of class, right? But as you probably have seen from the title of this presentation, and as you'll probably see on my kind of on this slide and the previous slides that I mentioned, is that there are a few different implementations of this thing. So there's a Marathon, Optomy, Open Liberty, Cumulusi, Wildfly, Helidon, and all the other ones. But there is one that is very, 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 very fast, and much faster than the other, because the other ones are kind of comparable. They're cool. There is Quarkus, and the Quarkus is crazy fast, and it can be crazy fast for two different reasons. One of them is just it's fast even in Java mode, but it also can do a binary native mode, so it kind of compiles everything down to binary. There is no Java, no nothing involved. It's just like bam, it goes into the binary mode, and it is very fast. Can't really underline that. And if you, I mean, we've done a few tests, especially when just Quarkus was released. It was really fun because we were having Mats and I would have this IoT talk where we would boot up many microservices to control smart lights, so like change colors and change brightness and all those kind of things, and different microservices would do different things, and we would deploy all those different microservices onto different app servers. So some of them would be run on Liberty, some of them would be on I don't remember now, Helidon, different ones. Tell me all of those that you saw on the list pretty much. And they would start up more or less in the same time. But then Quarkus was released. We added Quarkus, we ported one of the applications to Quarkus, and that was really fun to see because we were using Docker Compose back then, and that Docker Compose would kind of build start all those Docker images one after each other, one per microservice. And you would see that Quarkus would be done booting even before all the other Docker images would start logging to the console saying, hey, I'm about to wake up. And all that would happen in like sub-second kind of speeds. So that's really cool. And porting to Quarkus was actually a relatively simple task. So the easiest way probably is this. I mean, if you're kind of want to start with your project, and this is kind of what we did with this project because we wanted to simulate this getting started thing. So you basically download the Quarkus starter, very similar to the starter thing that you saw in MicroProfile. You copy the Docker and POM files into your project. You don't need the rest, but Docker files and POM files you need. So you just move that to your project. You change a POM file to your stuff that you've seen earlier in my POM file, right? We had like artifact name and version and all those kind of things. You move config to application.properties, update your cloud-build.yaml file if you're using that to accommodate for building on Quarkus, and you run. And then you'll run in Java mode. So it will be quick, but it can be quicker anyway, right? So we can actually try doing that. Oh, there's a question. Sorry about that. Let me see. Okay, so there's a question. Before we do that, let's ask a question. Let's do the questions. I'll just go back and open the other one. Okay, so is there any way to wake up container on request, not working all the time? Yeah, but that's what it does. So what it does, like for example, here is a Quarkus one, and that is not native. You saw the other one was native, was a bit further down. So what it does when I click on the URL, the request goes and it will wake up on itself. You can always obviously do like old tricks, the kind of the tricks, the old school tricks that we had in old school tricks, where that's interesting. That didn't work well. Of course, you can just like ping the service from time to time to make sure that it's not falling asleep and all those kind of things, but that's kind of against the whole point, right? The reason you're actually using this service is actually to save money, not to kind of fool it to spend more money, right? So what you can do is to either, like I said, to minimize an amount of instances, but still keep one, or you can, from time to time, you can ping it with like cloud servers, cloud function or something, just to keep it awake. Or if you know that most of your people will wake up and use it at 8 o'clock in the morning, you can just like ping it at 7:30 or something. But that's the really old school tricks. You don't want to do that. You want to make it a bit more more foolproof in a way. And one of those things is to make the boot time faster. Why not, really, right? Let's see. Let's try it one more time. If that fails, it's just something with the build, probably. Let's see if native is working. If not, then we'll just need to build that. Because it might be old. It might be an old instance. That one's supposed to be working. Hey, look at this. Did you notice the startup time? I mean, the same thing happened. Containers went up. Well, somebody was looking for resources. They spin up application. They did all this kind of things, and bam! It just, I didn't even notice the whole thing starting, and it was not running to begin with. But that is a native version, and with native version there is a little catch there. At least on when you build it on the cloud, it requires quite a bit of memory. So we had to upgrade build server to have more RAM and everything to be able to build. It needs, I think what Mats found out that it needed like 10 gigs. We needed to upgrade the server worker to build it to have more than 10 gigs of RAM. It can be something that we did wrong, but I think that's how it is. I mean, the native mode requires a bit of memory to build it, but then it will be really, really fast once you build it and you're done. So another question: is there any? No, that was the only question. Okay, I thought it was two of them. Great. So, now we're starting from cold start and going to the same kind of application in seconds, bam, and it's done, right? Let's see if it is actually the right application. I have not tried that. No, it's we can build it in other application and see how that works. So that's the trick. When you build native mode, you might need to have a look on your build configuration in the cloud. So it might require a little bit more resources to do that. But if we go back here, yeah, we got one of the requests. So our first application that we saw a bit earlier, we saw that we had actually a few requests here. As you can see, there are a few 200 requests, and there are none 400 requests, so no not found or any errors of any kind. That's kind of fun. Okay, that works. All right, let's go to a presentation. So now we're actually running our application in a container, automated in serverless platform or with the serverless offering, so you don't have to manage it. I mean, serverless doesn't mean there is no servers, right? It just means that you don't have to manage it. And so you kind of, somebody manages it for you or something. And now it's really also really fast to start up. So people don't really notice that it's actually been sleeping. And all of that you should be able to see in here in different steps. So here you'll see as a step 5, where we kind of switched to Quarkus and did all this fun things. And then with the last step is actually converting it to native mode and building it as the whole thing. So the URL should be here. And that one is actually not a very correct URL. Let me fix that. Or, well, technically it is correct URL. So this is everything. And the other one that is not everything is, oh. Let's do this. Workshop. So you have 2 URLs here. Where you can actually play around with things and see how it works. And let's have some chat. Okay, so there's a question. Is it also fast when having database connections? Yes, in my opinion, it is. And also, I mean, again, it depends on how you implement things, right? Because what do you do when if you just connect to a database? Yes, of course, it's gonna be fast. It's gonna be really fast. But if you connect to database and pull like 3 million terabytes of data in the beginning on the boot, it will not. So it is made to be fast, but it's up to you how you implement things when you build your application, right? So I have built a tiny little application that I'm using for some fun with some statistics and things. So basically, I'm scraping some APIs that are available, like for some social media and stuff like that, and then I do some stuff with the data just for fun. And I ended up kind of creating it all in containers on my machine. I haven't deployed it anywhere yet, so I'm kind of still stuck on what was that, step 3 or something, without putting it on cloud, because it's just me using it, so I don't really need to do that. But so put it in. I have one container with, was it Postgres? I think it's Postgres database, and the other container with Quarkus and Java. So I do, and then there is also something called Panache that is kind of on top of Hibernate that makes it even easier to use or to kind of to add or persist and get data from using Quarkus. So then I basically store quite a bit of data, denormalized data, because I don't really care about normal forms because it's not that much of the tables and everything. So I kind of flatten it all and put it there. And I read and write to it, and it takes just milliseconds with full-fledged, I think it's Postgres. I'm not sure if it's MySQL or Postgres. I'm pretty sure it's PostgreSQL. So yeah, and it's milliseconds. It boots up in very few seconds, and probably the longest thing it will take, it will just to find the right container with the database and just connect to it, and probably that's it. Any other questions? Any other comments or anything? Anything you want to share? You can unmute yourself as well and just let's have a talk. We have a few minutes. Probably around, if I calculated everything correctly, we should have around 6 minutes left.
Yes.
Yeah. So anything you want to comment on? This is one of the first times we're doing this. We're supposed to be doing this as a workshop, and this is definitely the first time I ended up doing it alone, and you know. We got the message yesterday, or Max got message yesterday. So we did not really have planned for anything, and instead of canceling the whole talk, I said I'll do it. So, you know, I hope it was smooth enough, but if not, there will be more chances, and we'll.
One question.
Yes.
I sent the chat. I don't know. Is it also?
Can you read it, because I don't see it? I don't think.
Okay. Is it also fast when having database connections?
Yeah, we talked about that. So that one I saw it and answered that.
Okay. Could you elaborate on testing? How would you approach it?
Come again? What testing?
Could you elaborate on testing? How would you
approach testing? No. It depends on what you want to test, because if you want to do like regular unit tests and everything, it's still going to be the way it is. But if you're going to do end-to-end tests, I mean, it's pretty much the way you would normally do in an application, right? If you want to do just unit tests of logic, you would just write it inside your application and just have it there. If you want to do end-to-end tests, maybe you want to kind of think about how you handle that. But it's going to be very similar to how you do a regular testing with any other application that you would have. What you can think about is that if I go back, but this is okay. So this was part of testing. So testing is not that much of a different. But if I go back to this, here you can see that you can also do a lot of monitoring. So monitoring is a different kind of animal, right? You can actually check how your application is doing. You can also check if your things are failing or not, or you can ping and see. You can also trace your requests. So there's a lot of things around monitoring that you might want to have a look into. And also cloud providers, like for instance, this one that we're running things on, would have its own monitoring thing. So there should be something called cloud monitoring. Explore here, there it is, right? So you can actually do monitoring of your applications here as well. And here you'll actually have all those traces and everything inside your cloud as well. But if you want to do it from your application and kind of let your application tell you things, or you can even do custom metrics. With metrics, you can also, I don't know if you've noticed that. I'll show you that too. If we go back to IntelliJ, yes, we did. Then we can have a look at, let's see if we go to, for example, here. I think we added that. Let me see if we did. Yeah, so here you, for example, you add counted. And counted, that is a kind of metric thing that comes from, as you can see here, from MicroProfile metrics that let you actually, for instance, count a number of times that service has been called. So if I go to that URL / metrics, I think, then I should be able actually to see it. And probably we did not protect it since it's a demo. Let me see. By the way, it's a very good idea to protect those kind of metrics from public access. We did not, again, because this is just a demo app, right? But let's see. Metrics page. Now it went to bed again, you know, fall asleep. So it will take some time for it to wake up again. And soon, I'll close that. Soon we should be able to see metrics. So you see it's the same URL, just /metrics. I'm not sure if it's open by default. Let's see if it is. Yes, it is. Okay, cool. So here you'll see all those things. All of those things are actually default, but some of them can be custom as well. So you can actually you can build your own custom stuff as well. So that is not the testing that you asked, but this is kind of a bit related because you need to monitor your applications. But with testing, just as you do with your regular applications, I would say. Any other questions, Nursel or anybody else?
I am looking. There is no another question. Thank you so much.
Thank you very much, and please give us feedback. I mean, this is, like I said, first time we're doing this workshop. First time I'm forced on a very, very short notice do it alone. So, any kind of feedback would be great to have. And you can find me on Twitter. This is, yeah, you can find me on Twitter. This is me. So feel free to ping me there if you kind of. Oh, I probably should switch to this.
Thank you so much.
Thank you very much. Thank you. Thank you all for coming, and thank you for listening.
Okay. Goodbye.
Bye-bye.
Have a nice day.